Like, can I know how many of you have gone through week 10 lectures?
No, ma'am. I didn't get time.
Okay. Okay. Week 9, did you watch? Uh, have you gone through week 9 sessions?
Yes, ma'am.
Yes, ma'am.
Yeah. Like, go through this week uh, 10 as well. Like, last week, I have started this thing now, like, regarding week 10. So, like, you have any doubts in the previous session which we have discussed? From then, we'll continue. Like, if you have any doubts, we will start with the doubt clearance and then I'll be continuing the rest of the content which I wanted to discuss. Okay. No doubts? Okay, then. Like, I have pasted the link of this YouTube channel in the chat box as well as in the calendar. So, since you are telling you are facing bit difficulty, I will start from the 4 year series. Like, just I'll give the brief of 4 year, I mean, brief formula regarding that, and we'll proceed. Is my screen visible?
Yes, ma'am. Visible.
Okay. So one thing, okay, from convolution, I will tell like uh, convolution to a system, like let x of t be the input signal and h of t is the impulse response, then y of t will be equal to x of t convolved with h of t. This is clear, right?
Yes, ma'am. Clear.
Okay, this part you have to know. Like here, h of t is impulse response. So, what is mean by impulse response? Impulse response means when we provide the input to the system, which is impulse, the response we get is h of t. This is impulse response. Like here, h of t to the same system. So, from the properties of convolution with the delta of t when it is convolved with h of t will get the same signal. That is h of t. Is this clear? Uh, like I wanted to go like in a flow. Like since you're facing some difficulty, just I want to give the rough idea and I want to move further.
Yes, ma'am. Yes, ma'am.
So, and the convolution formula you have to remember is pi of t is equal to integral of x of tau. I mean this, which is x of t convolved with h of t is equal to, which is y of t, equal to integral of minus infinity to infinity x of tau h of t minus tau d tau. This is a formula of convolution. And because shifting, doing, I mean, doing reversal and shifting and doing integration, it takes lot of time and computation. That's the reason we will be going to 4 year series. Like in convolution, we have properties as well, like commutative property. It will be following the commutative property, associative property, distributive property. You can have look into the properties of convolution. Then later Fourier series comes into picture. So in Fourier series, uh, so it is applicable for periodic signals. So any signal can be represented in terms uh, of phasors. So if let x of t is a periodic signal, it is a periodic, then it can be represented as sigma k is equal to minus infinity to infinity ak e power jk omega naught t dt. So where ak is 1 by t integral of in the duration of t x of t e power minus jk omega naught t dt. So it is an inner product. We are finding the inner product. So it is for periodic signals, and not only in terms of phasors. For the it can be fa- I mean periodic signals can be represented in terms of phasors, or it can be represented in terms of sine, sum of sine and cosine. So what if the signal is uh, aperiodic? So then we'll be moving on to the Fourier transform. So Fourier transform is applicable for energy signal, power signal, aperiodic signals, and it is not applicable for energy and power signals. So Fourier transform is for aperiodic signals. So let x of t be the signal. If we do Fourier transform, it can be represented in terms of x of j omega. So you will be having, why are we using this transform sign this? So like initially it will be in the time domain. So we are moving it. We are making it into frequency domain so that we'll be knowing how many frequency content is present in the signal. That's the reason we are moving from time domain to the frequency domain, and we'll be drawing the spectros of that signal. So x of j omega can be written as integral minus infinity to infinity x of t e power minus j omega t dt. So if you want to do inverse Fourier transform, it is x of t, inverse Fourier transform of x of j omega is x of t, which is equal to 1 by 2 pi integral minus infinity to infinity x of j omega e power j omega t d omega. Am I clear? I mean, now you understood why we came into Fourier transform.
Yes, ma'am.
How about others? Hello. Can I proceed further?
Yes, ma'am.
Yes, ma'am.
Because, okay then. So you are clear, right? How everything has come, why we are doing all this, or any more doubts? So we have discussed about duality properties also. Like one of the you have to remember the duality property. So duality property, what it is like? If it is if f of t Fourier transform is x of j omega, right? So what if x of jt, what will be the Fourier transform? So the Fourier transform of this will be 2 pi of x of minus omega. This is the formula. Okay. Duality property, it is important property you have to remember. And convolution property in the Fourier transform also you have to remember. That is y of t is equal to x of t convolved with h of t, right? Then y of j omega will be equal to x of j omega. This convolution will be converting into product when we do the Fourier transform. So this you have to remember. So this h of t is frequency response. It is called as frequency response of a system. So which can be written as h of j omega is equal to y of j omega by x of j omega. So frequency response is equal to Fourier transform of output by Fourier transform of input. Like if you have any doubts, you can also interrupt in between and you
Ma'am,
can ask me
ma'am,
question. Yeah.
ma'am, in duality properties, second, that is x capital JT equal to 2 pi.
It is capital A. Yeah, it is small x. So, and in the last session, we have discussed about LTI system properties from its spectrum. That is causality, invertibility, and stability. We have discussed. And in the last session, I have derived the formula for Fourier transform of step function. So Fourier transform of yes. Hello.
Yes, ma'am. Fourier transform of step signal and constant.
Yeah, constant we have discussed. Like, can you tell what is the formula for Fourier transform of unit step? Can anyone? It is pi times of delta omega plus 1 by j omega. So when omega is not equal to 0. This is a Fourier transform of step, and Fourier transform of constant. So constant signal can be written as, like, we'll assume this constant as k. So k is equal to k times of u of t plus u of minus t. So when we do the Fourier transform for this, it will be k times of, for u of t it is by times of delta omega plus 1 by j omega plus. So for, if for here we have to apply the property of reversal. So for x of t, it is x of j omega. How about x of minus t? Can anyone tell what is a formula, or what is a Fourier transform of x of minus t?
Pi delta minus omega plus 1 by minus j omega.
Yeah, pi delta of minus omega plus,
1 by minus j omega.
yeah, correct. So for x of minus to Fourier transform is x of minus j omega. From that we will be substituting here. Since delta signal is even signal, we will be writing it as, I mean, it will be represented as 0, right? Delta omega or delta minus omega will be same. So it will be pi delta omega plus 1 by j omega plus pi delta omega only will be writing minus 1 by j omega. Here both will get cancelled. As a result, we'll be getting 2 pi delta omega k for the constant. So one more thing which I last class I didn't discuss is about the Fourier transform of signum function. So Fourier transform of signum function, like how Fourier signum function looks like. Can anyone tell how it will be? Okay.
U of t minus time reversal of U of t.
U of t minus time reversal of, yeah, correct. So how U of t will be? It will be like this, right? U of t. And actually U of minus t will be in this way. And here it is minus. So amplitude need to be reversed. So it will be in this. Signum function looks like. So like uh so it will be like for U of t, it is Fourier transform is, can anyone tell? Like we have discussed in the last slide.
Pi lambda omega
I
plus 1 by lambda omega plus 1
it
by
is
j.
delta omega.
Sorry, delta omega plus 1 by
Yes.
j omega.
Yeah. When omega is not equal to 0.
Yeah.
For u of minus t, it will be like pi delta omega minus 1 by j omega, right? So there is minus in front of that. So u of t minus u of minus t, Fourier
Delta
transform.
delta minus omega.
Delta, yeah, here delta minus omega need to be there. Like I have told, like delta omega will be equal to delta minus omega because it is even signal.
Okay, ma'am.
So that's why I have it actually it is supposed to be delta minus omega. So it, which is equal to delta omega. Did you get this?
Yes, ma'am.
Since it is even signal, delta is even signal, it could be written as delta of omega as well. So it will be pi delta omega plus 1 by j omega minus pi delta omega minus into minus plus 1 by j omega. So it will be 2 by j omega will be the Fourier transform of signum function. Okay. Any doubts here? And another thing which I want to discuss is for differentiation. Okay, for x of t, Fourier transform is x of j omega. So there is for differentiation here I wanted to tell differentiation and integration. So d by dt of x of t, the Fourier transform will be j omega x of j omega. This is a Fourier transform. If it is in some orders, so d power n x of t dt power n, Fourier transform will be j omega whole power n x of j omega. This one you have to remember also. So coming to integration, so integral of minus infinity to 2t x of t dt. So integration why I have taken is integration is the area under the area, right? Area under the curve. We'll be taking from minus infinity to that particular point. So how it can be written in terms of convolution? Can anyone tell? This can be written as x of t convolved with u of t. Are you, did you get this? Uh, See, like I feel like we'll get more. We'll like to tell more like when you show some interest, right? If you be quiet and if you don't respond, how can we get interest? Okay, then I will proceed. It's up to you then.
And could you please repeat that integration part?
So integral. So integral. So this can be written as if you take in terms of convolution. So x of t. This is one formula. So x of t convolved with u of t, it is like we'll see like u of t, x of t is some random signal like this, and u of t will be like this, right? It will be 1. So first for convolution we'll be changing the axis. So let us change to tau axis and let's do the reversal. So I am doing a one signal has to be reversed, right? So I'll be reversing this u of t. Okay. So it will be minus tau and we'll be shifting. So from where we will be doing shifting? From minus infinity to till t will be shifting. Since it is u of t minus tau. So the limits will be from, it will be 1 from minus infinity to t, it will be 1. Here, till here, are you clear?
Yes, ma'am.
So we'll be applying the convolution formula. So convolution formula is minus integral of minus infinity to infinity x of tau u of t minus tau t tau, right? So here u of t minus tau is there. So it will be 1 till from minus infinity to t. Otherwise, rest of the part, else it will be 0, right? Other than this limits, it will be 0. So we'll be considering from minus infinity to t x of tau, and this will be 1 d tau. So this can be represented as this. Now did you understand? I mean, like here the variable doesn't matter. It can be, so here I have replaced t with tau. I mean, variable inside the integration will be same, right? If we replace with omega or some p like that. So this is how we got this.
Okay,
Now
ma'am.
did you get this? How we got this?
Yes, ma'am.
Yes, ma'am.
So like how thing is, like if you don't understand anything, you have to go with the fundamentals. What could be the reason? How it came? So then you will be understanding that. So like now we'll be doing the Fourier. So this is in the convolution state. So now what we want to do? We want to find the Fourier transform of the integration, right? So Fourier transform of this will be, so for wow, one thing I have discussed like convolution property for two signals in time domain will be in how it will be in the frequency domain for this.
For frequency domain, they will get multiplied.
Right. So it will be x of j omega multiplied with u of j omega. So it will be x of j omega into. So a Fourier transform of step function, what I have told, it is, what is a Fourier transform of step function?
Pi delta omega plus 1 by j omega.
Yeah. So we'll be multiplying it. So it will be pi x of j omega into delta omega plus x of j omega divided by j omega. So x of omega will be delta at 0. Other than that, it will be 0, right? Except at omega equal to 0, other it will be 0. So we'll be writing it as pi times of x of 0 delta omega plus x of j omega by j omega. Did you understand? Can I move further?
Yes, ma'am.
Okay.
Understood.
Ma'am, at omega equals to 0, the delta function will be 1, right?
Yeah, it is. It actually it is 1. Actually, it is supposed to be infinity, but it can be taken as 1 also.
Okay, ma'am.
Because we'll be taking like if it is small, area under the delta function is 1. So in that case, we can take 1. If it is omega means it will be 1 by omega. I mean, if the width is omega, then the height will be 1 by omega. It will be height. It will be the height. So it will be some. So epsilon will be taking as some 10 to the power of minus 200, very small number. So then it will be very large number. So like it can be taken as 1 also. Did you get it? Area will be 1. If you do area, this is a rectangle, right? Epsilon into 1 by epsilon will be 1.
Yes, ma'am. Got it.
I will discuss one thing. One that is for e power j s t Fourier transform we want. This question we have solved in the last session. Did you remember what will be the answer for this? In the last session, on Saturday session, I have discussed this. Okay. Can anyone tell me delta of t, what is a Fourier transform? Fourier transform of delta t. So it will be 1. For delta t, Fourier transform will be 1. So like according to duality property, for 1, Fourier transform will be 2 pi delta omega by duality property. So if you multiply in the time domain with the e power j omega t, then the Fourier transform will be, it will shift the frequency domain by minus s. Did you understand how we got this? So if it is minus JST, actually these are the properties. Like you can check the properties. These properties are being discussed in the week 9. Then it will be delta times omega plus s. Did you get this? Or any doubts in this part? So Fourier transform for e power JST will be 2 pi delta omega minus s. Am I clear? Am I making sense? Or you have any doubt in this?
Clear, ma'am.
Okay. So next part, what I want, what uh, next content is Fourier transform of periodic signals. X of t be periodic signal. Let it be periodic with fundamental frequency omega naught. So what will be the Fourier series for this as it is periodic? Can anyone tell me the formula for Fourier series? Can anyone help me?
Summation
Summation?
k tends equal to minus infinity to infinity ak e to the power j k omega 0 t.
Yeah. It is omega naught.
Yeah. Omega naught.
So what is AK here?
Fourier coefficient.
Your Fourier coefficient formula is 1 by
1
t.
by
Good.
t
1 by
1
integration
by t.
minus t by t to t by 2 minus t by
Ah,
okay t by 2 x t e to the power minus j k omega naught t dt.
yeah. Correct. Good. So we want to do Fourier transform for this. So it is a periodic signal. So Fourier transform of x of t will be like Fourier transform of sigma k is equal to minus infinity to infinity ak e power j k omega naught t. So like since this is constant, we are doing on the time part only will be, it can be written as sigma k is equal to minus infinity to infinity ak Fourier transform of e power j k omega naught t. So here from here, if we take this case which I have discussed, e power j s t Fourier transform is 2 pi delta of omega minus s, right? Here we are having e power, instead of s we are having k omega naught. So what will be the Fourier transform for e power j k omega naught t?
it will be 2 pi delta omega plus omega
Uh,
minus k omega
mm,
no.
correct. Good, good. So it will be sigma k is equal to minus infinity to infinity ak times of, this will be the Fourier transform for the periodic signal. So for the periodic signal, so I'll be, since it is periodic, I'll keep it as xp of t is equal to summation of k is equal to minus infinity to infinity ak 2 pi delta omega minus k omega naught. So Fourier spectra will be like this. So it will be multiplied, it will be the impulse train multiplied with ak coefficients, like ak times of 2 pi. So this impulses will be in this, which will be separated by the distance omega naught. So here it will be 0, it will be here 1 omega naught, it will be, so the weight will be like ak times of, here it will be a0 2 pi, here it will be a1 2 pi, here it will be a2 2 pi, here it will be minus omega naught minus 2 omega naught, a minus 1 2 pi will be the weight, a minus 2 2 pi. This is how spectrum for this looks like. This is clear, right?
Yes, ma'am. Clear.
Okay. So here it is summation, right? For the periodic we'll be using the summation. So that's why the Fourier spectrum will be in discrete. So what I wanted to tell is, so for periodic signal, So in time domain and frequency domain, I want to separate it out. So in periodic signal, so in time domain, if the signal is periodic, then in the Fourier domain, it will be discrete. In frequency domain, if it is periodic, then it will be discrete in time domain. So it is periodic in the time domain. Here we are having discrete. If we have the discrete signal, it will be periodic because of we can it could be due to duality property. Is it clear? Can I proceed or any doubts in this? You can if you have any doubts, you can open up and tell. Here you are there to learn, right? No, nobody is going to judge you. Don't think someone may judge you, or like if you have any doubt, you can approach, ask. Or can I go further next?
Ma'am, why do we use Fourier transform in real life? Like, what is the significance of using this?
Okay, why we are going to Fourier transform, you are asking.
Yes, ma'am.
Okay. Uh, so first you have to understand why we are moving from time domain to frequency domain. We'll be having okay, you know ECG signals, EEG.
Yes, ma'am.
Any idea? So
Actually,
these are the yeah. Tell.
ma'am, actually, I'm working on EEG and all.
Okay, that's great. So in time domain, we'll be knowing the uh, just we'll be knowing the graph. So we don't know what are the frequencies, right? So that's why we have to convert the time domain signal into frequency domain. So to know the frequencies, you'll be knowing for ECG, it will be like 0.5 hertz to 150 hertz. It will be the range. And if you
Okay.
use the filters, we'll be using it will be attenuated at high frequency. For the low pass filter, it will pass the low frequency signal, right? And it will attenuate and it will stop the high
Okay.
frequency, right? So this analysis can be done nicely in the frequency domain. Are you getting it?
Yes, ma'am.
So in time domain, we can't do all these things. What are the frequencies and all this? That's why we are going into frequency domain.
Okay, ma'am. So,
So
so just to analyze in frequency domain, we use Fourier analysis, right?
yeah. So like compared to time domain, we have more benefits in the frequency domain.
Okay.
We have more options and more usage in the frequency domain. Like this is one example I have given.
Yes, ma'am.
So
Good.
now you got why we are using this Fourier transform and all this
Yes, ma'am. Got it.
Fourier series, Fourier transform.
Yes, ma'am.
Okay,
Thank you, ma'am.
okay. So next topic is relation between Fourier series and Fourier transform. So relationship between Fourier series and Fourier transform. So like Fourier series is for periodic signal, right? So periodic signal can be represented as x of t convolved with impulse train of n is equal to minus infinity to infinity delta of t minus nt. Do you know how it has come? Like any periodic signal can be represented in by x of t, which is convolved with impulse train. Okay. For this, like this thing I have discussed in the previous session. I mean, long ago. If we take rectangle signal, and this is impulse train, right? The summation of delta of t minus nt, it will be like impulse trains, infinite impulse trains. 0, it will be separated with t, 2t, minus t, minus 2t. This is how this look like. So when we convolve with this signal, so I have told from the properties of if we convolve x of t with the delta of t, will be getting the output as x of t. If it is x of t convolved with delta of t minus some t naught, it will be shifted, right? X of t minus t naught will be shifted. So this will be like this. I mean, when we are convolving, here we'll be getting in this. Did you understand why how we got this now? This formula.
Yes, ma'am.
Okay, good. So, like from the convolution property, if you want to know the Fourier transform, we'll be applying the Fourier transform for this. So, Fourier transform of xp of t will be equal to Fourier transform. So, this Fourier transform of convolution will be product, right, in the frequency domain. So,
Yes.
it will be like, yeah. It will be x of j omega multiplied with Fourier transform of
You are not audible.
summation. I'm not audible. How about now?
Yes, ma'am.
You're
You're
audible.
audible.
Okay. The one who asked, am I audible now?
Yes, ma'am.
Okay. So it will be delta of t minus nt, where n is equal to minus infinity to infinity. So, like impulse train, in the previous slide, I have discussed like for the periodic signal, Fourier transform for the periodic signal will be summation of k is equal to minus infinity to infinity ak 2 pi delta omega minus k omega naught, right? For the periodic. So similar property I will be using here. Same formula. So then it will be x of j omega into summation of k is equal to minus infinity to infinity ak 2 pi delta of omega minus k omega naught. So for AK will be AK for delta will be 1 by T for delta signal. I mean A naught will be 1 by T. Hello. Do you know why it will be 1 by T? If you use this formula, AK is equal to sigma 1 by T, integral of minus pi by 2 to pi by 2 delta of T e power minus jk omega naught T dt. So this will be delta of T will be 1 only at 0, right? So we'll be writing it as it will be like this, omega naught into 0. So e power something will be, e power 0 will be 1. So it will be 1 by T. So here AK, A1, everything will be 1 by T. So AK is equal to 1 by T, which is equal to K of j omega times summation of K is equal to minus to infinity 2 pi by T delta of omega minus K omega naught. This is a relationship between Fourier series and Fourier transform. Did you understand? Or any doubts in this?
Ma'am, I have doubt in that Fourier transform of impulse train. How did we got that in
This
frequency domain?
okay. In frequency domain, where you are asking regarding graph, till graph you are clear this part.
Yes, till graph. This is clear. In this xj omega
Oh,
into sigma.
okay. So in the summation, so this is impulse train, right? Which is periodic.
Okay, 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 ma'am.
It is
So
periodic now. In the previous slide, I have discussed. Okay, I will write and mark it in different color. So here, Fourier transform of periodic signal, I have derived, right, like Fourier transform of periodic signal. It is summation of k is equal to minus infinity to infinity ak 2 pi delta of omega minus k omega naught. This formula only I have used.
yes, I'm now got it.
From this is how we got this by using that formula. And ak will be, ak I substituted as 1 by t for delta signals. Now you got it, right? Can I move further?
Yes, yes, ma'am.
Okay. So next part is solving ODEs using Fourier transform. Second. Solving ordinary differential equation using Fourier transform. So we'll be taking the RC circuit. So it could be represented as in the schematic diagram I'm writing. So here we are input is x of t and RC are in this RC circuit. So we want to find the output across capacitor and the current flowing is I times of I of t in the circuit. So it is a X of t is a voltage, input voltage, and y of t is output voltage. So x of t can be represented as Ri of t, since this current is flowing in this voltage in across the resistor can be represented as R times of it plus 1 by c integral minus infinity to infinity it dt. Am I clear? Hello?
Yes,
Like
ma'am.
just I have used KVL in this. So x of t will be R of it plus. So this is a voltage, right? This can be represented as phi of t. So now, so I of t can be represented as I equal to dq by dt. This we know, right? So like V is equal to q by c for the capacitor. And I is equal to dq by dt. So where it is a charge, q is a charge. So it will be d by dt of Vc. So since c is a constant, it will be coming out. It will be dv by dt. So I of t can be written as this. So I am replacing with c into dv by dt. So here V is voltage across the capacitor, right? So voltage across the capacitor is y. So it is y of t dt plus y of t equal to RC d by dt or d by dt plus 1. Why I am taking out y of t? So it will be like this. I am finding the Fourier transform for this. So it will be x of j omega is equal to. So RC is
Then that
constant.
is,
Yeah, yeah.
ma'am. Here that is y of t is different, is in differentiation, right? So how we can take out this?
Yeah, okay. It can be taken out commonly because y of t can be taken out. Or okay, we'll do in this step only. With this step only, we'll do. Okay.
Okay.
So RC is equal to like for differentiation, I have told how it can be written. Differentiation of x of t can be written as in the Fourier transform. How it can be written? Can anyone tell me that property?
J
J
omega
omega and
and x j
Yeah,
omega.
j omega. Huh. So here instead of x here it is y no. So it will be y j omega plus y of j omega. So I am taking this j omega common. Yj omega I will be taking common. So it will be written as y of j omega. So now I want to find the frequency response, how the system is working. So frequency response is represented as, what is the frequency response? It is h of j omega, right? Which is frequency, which is Fourier transform of output by Fourier transform of input. So from this, so if we shift, I mean this x of j omega to other side and this part to left hand side, it can be written as 1 by 1 plus j omega rc, right? So this will be, this can be written as 1 by, so rc I'll be taking it as common. It will be 1 by rc plus j omega. So there is one formula like 1 by a plus j omega, like its inverse Fourier transform is e power minus at ut. So this can be here a is 1 by rc, so it can be written as, so now I am doing inverse Fourier transform in order to find the impulse response of RC circuit, where we are fine, where y of t here is output across the capacitor. You have to keep this in mind. So it will be 1 by RC. So h of t, which is the impulse response, is equal to 1 by RC into, so 1 by, so it is in the form of a plus j omega, right? So it will be written as e power minus 1 by RC t ut. Am I clear how we got the impulse response for RC circuit?
Yes, ma'am. Got it.
Okay. Similarly, like I'm professor has been discussed about RLC circuit. You can watch that as well. Like if you have any doubts, like this is a homework for you for RLC circuit. Like you can tell this what is, you can work on it, how for the RLC circuit how it is gonna be. Okay.
Okay, ma'am.
Okay. Uh, so can I discuss some problems? Can
Yes,
I
ma'am.
give you some break? Yeah, can I give you some break and get back, or shall I proceed the session?
It's fine.
You can proceed,
Yeah.
ma'am.
Okay. So the question is Fourier transform. We have to find the Fourier transform of x of t plus t plus x of t minus capital T. Can anyone tell what could be the Fourier transform for this? Hello? We have to use the shifting property, time shifting property. So we have the, yeah. Someone is ready about to tell.
Ma'am, x j omega plus into e to the power j omega t0.
Into e to the power of
J omega
yeah,
t. That is t,
yeah.
yes. T.
Yeah. Correct.
And for minus, that is minus.
Yes. Correct. If it is plus, it will be plus. It is minus, it will be minus. So that this formula I'm using in this. So it will be x of j omega into e power j omega t plus x of j omega into e power minus j omega t. So I'll be taking x of j omega as common. It will be e power j omega t plus e power minus j omega t. So cos theta is equal to 1 by 2 times of e power j theta plus e power minus j theta, right? So, uh, so from this, just instead of theta here, we are having omega t. So e power j theta plus e power minus j theta will be 2 times of cos theta. So I am substituting this here. So as a result, this is, so then it will be x of j omega will be into 2 times of cos omega t. Like for a signal, if it is shifted, I mean, if it is advanced and delayed by the same constant, and if they are added, this is the formula we get in the Fourier transform. Clear?
Yes, ma'am. Clear.
Yes, ma'am.
Okay. Okay. Similarly, we'll do Fourier transform for. Now you have to help me with this. Delta of t plus 2 plus delta of t minus 2. So what will be the Fourier transform for this? It is similar, right? Instead of x here we are having delta, and instead of capital T we are having 2. So first you have to know what is the Fourier transform of delta of t, you have to tell me.
It is 1.
Yeah. So it will be 1 time of 2 into cos omega into 2, right? So it will be 2 cos 2 omega. Did you get this?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay.
Ma'am, we can put direct formula, na ma'am? Yeah.
This formula you can use, no? It is, see, like the same signal is shifted by t. I mean, advanced and delayed by the same thing, and they are added. Then we will be getting this. So I have used this formula in this. Or you can use in another way. You can write by using steps also.
Okay, ma'am.
Here I use the direct formula.
Yes, ma'am.
Okay. So other question is, let x of t be a signal which is represented as sine of 2 pi t into e power minus t ut. So now we have to find Fourier transform for this. That is x of j omega we have to find. So what is the formula of x of j omega? It can be written. I have discussed about the formula. It will be integral of minus infinity to infinity x of t e power minus j omega t dt, right? So like here sine theta, sine theta, we know the formula, right? I'll write the formula in other color. So sine theta is equal to e power j theta minus e power minus j theta by 2j.
2J.
So same formula I'll be applying here. So because we are having e power minus theta minus t here, and since it is u of t, it could be from 0 to infinity. So 1 by 2j into e power j 2 pi t minus e power minus j 2 pi t into e power minus t. U of t I am not considering because I have taken the limits from 0 to infinity. E power minus j omega t dt will be getting. So it will be integral of 0 to infinity 1 by 2j. I am taking it as common. So it need to be multiplied. Here e power we are having. So it will be e power j 2 pi t minus t minus j omega t minus e power minus j 2 pi t minus t minus j omega t. So 1 by 2j integral of 0 to infinity e power, I am taking minus t as common from all the things. So it will be 1 minus j 2 pi plus j omega minus e power minus t 1 plus j 2 pi plus j omega. So we'll be doing the integral of this. So it will be e power minus t 1 minus j 2 pi j omega by minus of 1 minus j 2 pi plus j omega, where integral is from 0 to infinity, minus e power minus j minus t of 1 plus j 2 pi plus j omega divided by minus of 1 minus j 2 pi plus j omega 0 to infinity. So can you, yeah,
Ma'am, 1 plus 2 pi. Second part.
1
Denominator
1 plus,
j 2 pi.
yeah, 1 plus j 2 pi. Like, can you substitute the integral in that? I mean, can you substitute the limits and can you tell me the answer? What will be the resulting one by after substituting the limits? Just calculate and let me know. Are you doing it? I'll give you a minute and just let me know what will be the answer. Are you doing this or should I explain? Hello? Can anyone respond? Am I audible?
Ma'am, it is 1 upon 2j into
1 minute.
1 by 1 minus 2 pi j plus j omega minus 1 plus 2 pi j plus j omega.
Can you tell it once again? It is
1
Yeah,
by
tell.
2j 1 into 1 by
1 by
1
2j
minus 2 pi j
into
into 1 by 1 minus 2 pi j plus
wait, I'm writing. Into 1 by 1 minus 2 pi j plus,
plus j omega
yeah,
minus 1
1
upon
second, plus j omega
minus
minus,
1 by
mm,
1 plus 2 pi j
yeah,
plus j omega.
yeah, correct. So if we take the else, I mean, if you do the,
It can be more simplified, but I am
yeah,
still.
will you simplify and tell me?
Yes, ma'am.
Okay. Okay, I'll do along with you. So it is, we can write it as 1 plus j omega minus 2 pi j, right? This term, denominator. And this as 1 plus j omega, just rearranging the terms. So it is like, we'll take this as a, I mean 1 plus j omega as a. Yeah. Did you get the answer?
Ma'am, I take common of j. 1 plus j into 2 pi plus omega. That's I
Yeah.
take
You can
common.
do in that also. Like, yeah, you can do in that as well. But this is the like simplified version I'm telling. Because it will be like a minus b. Like if we take 2 pi j as b and a plus b. So we know a minus b into a plus b will be a square minus b square, right? So it will be like denominator will be uh 1 plus j omega whole square a square, which
Minus 2 pi j whole square.
whole square. So numerator will be like 1 plus j omega plus 2 pi j, since it is minus in
Ma'am,
front of
after
here.
reduction, j will be removed.
Yeah, j will be removed after
Then
reduction.
uh, with common of j, I got 2 pi divided by 1 plus 2 pi plus omega whole square.
How what you got? 2 pi?
2 pi divided
Uh,
by 1
hmm.
plus within first bracket 2 pi plus omega whole square. Is it correct or not? I don't know.
2 pi plus omega whole square.
Yeah. One separate, ma'am. Yes.
One is separate.
Yeah.
1 second. Will be 4 pi square. Give me a second. 2 pi. But there is J is there, right?
Ma'am, can we put j square equal to -1?
Yeah, we can keep.
Uh,
Uh,
that
so
is, if we take j common, then it will be 1 a square minus b square formula. No?
uh
I did like that. Or it is wrong. No?
okay. Like can you send me that?
Yeah. No, ma'am, it is
Uh,
wrong. Because after taking j, first part is 2 pi
J
minus
is
omega.
common, you have to
Yeah,
take.
yeah, yeah, yeah.
I think you
I am
have made
wrong.
some mistake.
Yeah. I am wrong, ma'am.
Okay. So here it will be 1 minus 1 plus 2 pi j minus j omega. So j omega will cancel. 1 and 1 get cancel over here. So it will be 1 by 2j into 4 pi j by 1 plus j omega whole square minus 4 pi square. J square into j square is minus 1. So it will be 1 by 2j. So here j and j gets cancelled. 2 1 j 2 2 j. It will be denominator will be 2. Not denominator. Numerator will be getting 2 pi divided by 1 plus j omega square. Here minus into minus plus 4 pi square. This is the answer, final answer. Did you
Yes,
get
ma'am.
this?
Yes. Now I got this, ma'am.
Okay.
Yeah, it's okay.
Okay. This is the final answer. So other question is, so they have given a signal which is x of t. It is 1 minus t between 0 between 0 and 1, and it is 1 plus t between minus 1 to 0 and 0 otherwise. So what is this signal? Can anyone tell me? Can anyone tell me what could be this signal? It is a triangular signal, right? Am I right?
Yes, ma'am.
Yes, ma'am. Yes,
It
ma'am.
is a triangular signal. So, so here we will be using some properties for finding the Fourier transform for this. So, when we'll be getting the rectangular signal, what is the can anyone tell me the relationship between the rectangle signal and the triangular signal?
So convolution of two rectangle is a triangle.
Yeah, correct. Good, very good. So, which is of equal duration? This is a note here you have to tell. Like the time duration, I mean the rectangular pulse duration in both the cases need to be same. Then only we'll be getting the triangle, right?
Both should be identical.
Yeah, both should be identical. So, it will be from minus 1 by 2 to 1 by 2 convolved with 1 by 2 to 1 by 2. Am I right? This can be written in this form. So, this
Yes,
is a
ma'am.
convolution of two rectangular signals of duration uh, from minus 1 by 2 to 1 by 2. So for rectangular signal, it is sync. We know that rectangular we'll be using. So this is in time domain. So in frequency domain, we have to. So it has to be, I mean, convolution will be converted into multiplication, right? In the Fourier transform, according to the Fourier transform properties, convolution will be converted to multiplication. So rectangular of j omega into rectangular of j omega. I mean, what is the Fourier transform of rectangle multiplied with Fourier transform of rectangle? Correct? So what is the Fourier transform of rectangular signal? It is sinc, right? Hello. Like this is discussed in week 9, I guess. Fourier transform of rectangular signal is sinc.
Okay, ma'am.
Okay, you can refer that video as well once. Or like you can use that formula like integral of, so minus half to half, it will be 1 e power minus j omega t dt. I'm using this formula like x of j omega for this.
Ma'am, can
So
you
if
please
you saw,
provide a sheet? Hello?
yeah.
Ma'am, can you please provide a sheet for standard Fourier transform of particular signals? Like this is a rectangular Fourier transform is sinc of omega 1 to pi, like that.
Okay. We'll provide. So like just go through this, like it is already discussed. Like we'll provide you the sheet then.
Okay, ma'am.
So it will be, yeah, okay. Sinc omega by 2 pi into this is multiplication, or like I'll write it in dot, sinc omega by 2 pi. So it will be sinc square omega by 2 pi. Did you understand? Like what is a Fourier transform? How we got this? Just like we have used the properties, so it becomes very simpler. Okay. Any doubt in this? Can I move? Can I proceed to other problem?
Yes, ma'am.
Okay. So like an LTI system is described by an LTI system described by the differential equation. So the differential equation is d square pi of t divided by dt square plus 5 times of dy of t by dt plus 6 pi t is equal to 4 times of d by dt of x of t. So we have to find frequency response, that is h of j omega. So can you tell me how to do this? Can anyone? What is a Fourier transform? This is easy problem only. What is a Fourier transform of differentiation?
J omega square y j omega.
That is
Yeah,
j
j
omega
omega.
into x j omega. Yeah.
J omega square
Yes, ma'am. J omega square y j omega.
into j omega. So 5 times of this will be j omega
J
into
omega
y
into y j omega.
plus
6 y j omega.
yeah equal to 4 times of j omega into xj omega, right?
Yes,
So
ma'am.
we'll be taking the common in this y j omega. So what we have to find, like what is a what is the relationship between frequency response and Fourier transform of input and Fourier transform of output?
H j omega equals to y j omega upon x j omega.
Y j omega by x j omega. If we find this, we can find frequency response, right?
Yes, ma'am.
So we'll be doing that. Am I right?
Yes, ma'am. You are right.
So I am rearranging the terms. So we'll be getting, after rearranging, it will be j omega by j omega square plus 5j omega plus 6. So which is h of j omega. So 4j omega. Here, uh, here like we can factorize it, right?
Yes, ma'am. Yes, ma'am.
So what is the factorization of this? Like
J
if you
omega
take
plus,
j omega as x or something.
ma'am, j omega plus 3 into j omega plus
Yeah,
2.
correct. Good. So this is a frequency response of this. Then how can we find the impulse response? How to find the impulse response? What is the impulse response? It is h of t, right?
Inverse of h of j
Yes,
omega.
ma'am.
Yeah, we have to find the Fourier transform of h of j omega. So we'll be getting, or should I give it to you as a homework how to find the inverse Fourier transform, or should I explain you?
Ma'am, first explain, then give us a problem regarding this.
Uh so okay, like so how this can be written? We have to factorize it. I mean, we have to convert this in terms of partial fractions. Okay. I mean, this is in this form,
Yes,
right? Like one thing we know, one formula, like for e power minus 80 ut, if we do the Fourier transform, it is 1 by a plus j omega. In the previous one of the slide, I had told this formula. Did you remember?
yes, ma'am.
Yes, ma'am.
So, so we have to make in that form. Like this is the multiplication of that. So we need to use the partial fractions. Can you use a partial fractions for this and tell me the split?
Yes,
Hmm. What will be the result you tell? No, maybe you can keep some x or y. If you feel that as complicated, you can do that in that way.
Ma'am,
Yeah.
4j omega by j omega
1 second, 1 second. 4 j
4j
omega
omega
by
by j omega plus 2 minus 4j
j
omega by
omega
j
plus.
omega plus 3. Yeah.
Wrong. It is wrong. We'll be getting as.
No.
Okay, I will do along with you. This is not. I mean, coefficients are not correct here. It will be, one will be 8 and one will be 12.
Yes, ma'am, got it. 12 and 8.
Yeah, that is
So
correct
12
one.
upon j omega plus 3 and other is minus 8 upon j omega plus 2.
Could you come again?
So 12 upon j omega plus 3 and
Uh,
another is minus 8 upon j omega plus 2.
yeah, correct. That is correct. Okay, I will tell how to do. So it will be second. So it is 4 by j omega. So h of j omega is 4 by 4 j omega plus 2 into j omega plus 3. So this can be written as a plus 2 plus j omega plus b by 3 plus j omega, right? For j omega, if we take the LCM, it will be 3 plus j omega plus b times of 2 plus. So I am cancelling the denominator in both the sides. I am considering only this. Are you getting?
Yes, ma'am. I wrong. I did wrong.
So here what we have to do is, I am taking j omega as minus 3 in one case, so that this term will be 0. If we take minus 3 here, it will be minus 3 plus 3 gets cancelled. So b times of 2 minus 3 will be minus 1. So b will be 12, will be getting. Okay. And similarly, if we substitute j omega as minus 2, then we'll be getting 4 into minus 2, which is 8, minus 8. And here b term will go 0 since we are taking it as minus 2. 3 minus 2 will be 1. So here a. So a will be minus 8. So as a result, j h of j omega will be minus 8 by 2 plus j omega plus 12 by 3 plus j omega. So it will be minus 8. So one thing which I told is 1 by a plus j omega inverse Fourier transform will be e power minus at ut, right? So it will be e power minus 2t into ut plus 12 times. Since it is constant, it will be same. So it will be e power minus 3t ut will be the answer.
Ma'am, we have to
Like
write inverse of h j omega, no, ma'am? That is h
inverse of, yeah, inverse of
f
this only I am
inverse
doing,
ft.
no?
Yeah.
Yeah, this is the inverse only I am doing.
Okay, ma'am.
So this will be the impulse response. Did you understand or any issue with this? Hello?
No, ma'am.
Or any doubts regarding to the today's session? Any doubts? Ankita has asked, ma'am, have you asked? Yeah, yeah, yeah. It just I got confused between that, Ankita. Yeah, it is like uh, capital X of JT will be equal to 2 pi small x of minus omega will be the thing for the answer in the chat box.
Ma'am,
Okay, any
can
doubts?
we write 2 pi x minus j omega there? So, what
Can
is
be written. Yeah, minus j omega can be also written there. Oh no, we can't write because x capital X of JT is in the time domain, right?
yes, ma'am.
Once I'll check that Soma Mandal.
Yes, ma'am.
Mm. Any more doubts?
Because this 10-week graded assignment, there is a question for like this one question I have. In.
Okay, I will check it then.
Okay, ma'am.
Mm. Any more doubts?
Ma'am, actually